Good morning.
Good morning.
Good morning.
Nice to see you guys. Traditionally, I will check attendance right now. Can you hear me well?
Yeah.
Okay. And again, I hope that you all received yesterday our link to our yesterday's lecture. Did you?
Yes.
Okay,
Yeah.
good. So today is April the 8th, and I'm starting. Andrew?
Here.
Okay. Tima?
Hello.
Hi. Lorraine?
Here.
Lynn?
Here.
Juanita?
Here.
Christian? Okay. Yuran?
Here.
Gabriel? Divina? Divina? Kobe? Chantal?
Here.
Ricardo? Hochito? Gongsi?
Here.
Kyle?
Here.
Matthew?
Here.
Julian? Here. Okay. Nathan?
Here.
Alejandro?
Here.
Okay. I think it will be in your benefits if I release a little bit information about your test. Would you like to get that information?
Yeah.
Yes, please.
Okay. First, how many problems in total? 10 problems. But they are not really big, huge problems. And you will have a full hour to solve these problems. These problems will be offered to you through Wiley Plus. And the name of that test, it is actually test number 2 for us. I will probably even will call this like test number 2, even though on Wiley Plus it should be actually test number 1, because before that we had in-class test. But again, this is the test number 2. Maybe I will call it like, say, test of chapters for chapters 4 and 5, but it is test number 2. Again, it will have 10 total problems, and definitely there will be combination of problems with the material from both chapters, from chapter 4 and chapter 5. But these chapters are very related, and in both of chapters we were dealing with exponential models, and equations, and quite often solving these equations we were using logs, even though if originally it was not a logarithmic equation. So which means this is that type of material. I included very, very easy problem with the limit, like let's say sketching certain function which fits the following requirements. Let's say limit when x is approaching, let's say positive infinity, limit is equal to, let's say 5, and limit and x approaching, let's say negative infinity, limit is equal to the certain number. So this is that type of problem. Besides that, there are quite short, we call them word problems because they are verbal problems, in which you are asked to get an equation for the model describing that situation in that particular paragraph, or just to actually solve completely the problem. If, let's say, it is about doubling time, what would be the half time or doubling time for the certain condition. And these are all that type of problems which we worked with. We solved many of these problems, and nothing should catch you by surprise. And this is a material which is extremely close to problems from your homework assignments and from your online quizzes. That's it. And again, you will have only 1 hour to do that work. This why be on time, because there will be no extension at all. Unfortunately, some students, they like to be late even for our virtual lectures. It is not a good thing, because everyone should be already there when I participate this meeting. This why, again, keep it in your mind. You will be having starting time and ending time very precise. Try to be on time. And again, it will be work. Your work will be absolutely identical with what you do with your homework assignments and your online quizzes. Do you have more questions?
I have a question.
Yeah.
Are we gonna have a Zoom meeting? Are we gonna have to go to the Zoom meeting during that time tomorrow? Or
You know what? You can go directly just to Wiley. And
okay.
because I do not want to interrupt, I will be available. So if you like to log in, you can see me. But for you, it is not a necessity, because we have 1 hour academic hour meeting online. So, and you will have actually practically one regular 1 hour for your work. You will have
Okay, thank you.
about 10 minutes more than usually we have this in the class settings.
Okay, thank you.
And definitely I will take an opportunity to discuss these problems the next time when we meet, to maybe answer some of your questions, because again, this is what we usually do, analyzing all problems from our quizzes and tests, and I will try to keep the same tradition, but it will be after you take that test.
All right.
Do you have more questions?
No, thank you.
Excellent. Now, this is regarding some complaints about not being able to see homework number 16. Is it true that I understood this correctly? Because some people were complaining that they were not able to see homework number 16 yesterday. Yes?
Yes.
And
Yes.
it was coming. It should be open today already at 12. So can you see it now?
Yeah, it's open now.
Yeah, so this is normal. This how I schedule that, because again, we just starting right now our review of trigonometry. And if you can see, this is already material from chapter 7. And trigonometry here has, I think, 3 chapters. So and this why you should not complain, because you definitely, no, I'm not saying you should not complain. You do not have a right to, no, I really apologize. Maybe you did not understand me properly. What I'm saying is yesterday after I received these complaints, I checked everything on Wiley Plus, and there was not even need to contact their representatives, because it was clear to me about the starting time and date for that assignment. This is why I checked that yesterday right away after we ended our lecture. Can I start now talking about trigonometry?
Yes, please.
Yes, please.
Yes. And again, I definitely will try to send you a link for today's lecture. But again, trigonometry is a very challenging subject in math. It has so many details. It has only 6 trigonometric functions. I'm talking about families of functions, plus 6 inverse trigonometric functions. But practically, we are dealing in trigonometry with 12 families of functions. But at the same time, even number of families of these functions is very limited. It has tons of different details, tons of different formulas, 3, 5, 4,000 tons of different approaches and methods. This is why definitely we will be having very short time bracket to review trigonometry. And please be very serious about this material, because I cannot pretend that you never had trigonometry before. You just had trigonometry 1 level down from your class, and we are assuming that if you pass 3 class to come to pre-calc class, you should be aware of trigonometric material. But let's see what is going on in our textbook in these particular chapters. I'm going back right now to the table of contents, and look what happens here. Chapter 5 was the last one which we worked with, and it was about logarithmic functions. Chapter 6 is a transformation of functions and their graphs. We already talked about this, and I am planning to talk a lot about transformation of graphs when we start talking about graphs of trigonometric functions. This why it doesn't mean that I'm ignoring material from chapter 6. No, it will be covered, but it will be covered. It was already covered through properties of previously covered functions, and I will also cover more details talking about graphs of trigonometric functions. So if you look at this table of contents, you can see chapter number 7 is trigonometry and periodic functions. Chapter 8, triangle trigonometry and polar coordinates. Yes, we will cover polar coordinates with quite many details. For probably many of you, maybe it will be in new material. Number 9, trigonometric identities, models, and complex numbers. Yes, we will be talking about that also. If you look at chapter 10, it is compositions, inverses, and combinations of functions. We already covered this material, but there is a plenty of room to cover and compositions and inverses and different combinations covering trigonometry. And I am really planning to talk about chapters 11 material, polynomial, and rational functions. This is a mandatory actually material for this class. That's it. So I will be covering trigonometry, sometimes jumping from one chapter to another. Yes, it all will be about trigonometry because there are 3 chapters, 7, 8, and 9. So please don't be surprised because I will be probably changing the sequence of covering this material. Is it clear?
Yes.
Excellent. And first thing, what I'm going to say just right now a little bit is about periodic functions. I would like to give you about 1-2 minutes to think how you can explain the meaning of that function is periodic in your own words. And after that, we will continue our discussion, including me. So again, my question addressed to all of you is, what do you mean when you say function is periodic? And while you do that, I will check right now attendance of people who did not reply to when I called their names, and I will continue from there. So I will go right now to chapter 7. Chapter 7. Okay, so Gabriel,
Here.
Divina,
Here.
Kobe, and practically that's it. Okay, dear ladies and gentlemen, would you like to share with me? Because periodic functions are not only in trigonometry. In other parts of math, we also can deal with periodic functions. Okay, do we have any volunteer who wants to share? Should I call names to start this discussion? I can.
I can
Okay, go ahead.
so like in my own words,
Yes, definitely.
a periodic function is a function that repeats a pattern, and each repetition is the same amount of time.
You know what? I really liked a lot. I liked a lot specific word in your explanation. Guess which word was such a beautiful for me in your explanation?
Repetition?
Exactly. Because if we like to just in our words to describe the nature of periodic functions, this is a function with repetitions, as you say, repeating the pattern. But we need to be a little bit more specific. It will be exactly repeating the pattern which we take out of the certain interval. And if we measure the same length, which we already measured for this interval, and break our domain into many pieces with identical length, I'm talking about on x-axis, we will be having absolutely identical graphs on all these pieces, right?
Yeah.
So practically, your description, your opinion was really nice and precise, even though you had some kind of apology saying, oh, I'm describing this in my own words. It was really good explanation. So thank you very much.
Thank you.
You deserve the compliment. I'm not the person who will shower people with compliments if I do not have a good reason for that. So, yes, but this is a, we can say, graphical approach to that explanation, right? And which is not bad, because when we have graphs, we are using our visualization, and visualization plays tremendously important role in everyone's life. So, but how can we describe this mathematically, writing this as a sentence? First of all, let's call our function f at x. Can we? Yes?
Yeah.
And I'm not specifying the any formula right now for this particular function. I'm just using general approach. F at x is a function. And let's say it has its domain capital D. So practically, this is what I just wrote on the piece of paper. Function is f at x. Next to that, after comma, you can see that capital D. It is a domain of that function. And now I'm starting. If exists certain number t, I hope everyone remembers that symbol of turn to the side capital E. In math, it means exists. Or if you like to write this as a word, you can do that. If exists such a number t not equal to 0, such as for any, and again, I'm using symbol of any, it is upside down capital A, exists t not equal to 0, such as for any x from the domain f at x plus t equals f at what I wrote using only math symbols. If function is given, it is f at x, d is its domain. If we have such that number t not equal to 0, such as for any x from the domain of that function, f at x plus t equals f at x, then we call that number t a period of that function. But we have some other requirements for that number t. Why? Let's recall any of trigonometric function. Let's say use the easiest one. Y equals to sine x. Y equals to sine x, which is the basic trigonometric function of sine x. I hope you remember its period. What is the period of sine x? Guys, I asked everyone a very easy question. Do you need my help? Guys, I cannot hear you.
Is it
Yes.
2 pi?
2 pi.
Yes, it is 2 pi. But look what happens here. If 2 pi is a period for sine x, then any multiple of 2 pi also will be a period. So, and 4 pi will be period, and negative 8 pi will be period, and 1000 pi will be period. Can you see I'm right now actually mentioning all multiples of 2 pi, positive or negative multiples?
Yeah.
Yes. So in other words, we can now be very confused because we now just talking about periods for sine x can say that that function has infinitely many periods. This is a big confusion and it can cause big mathematical headache. This is why in math, mathematicians decided to eliminate that headache, and listen what they decided to do. They decided to have the smallest positive number as a period. Again, choosing from infinitely many periods of that function, we are going to deal only with the smallest positive value. This is why we came back to 2 pi. Is it clear?
Yeah.
And if we decide to talk about 6 basic functions in trigonometry, and 6 basic functions are y equal to sine x, y equals to cosine x, y equals to tangent x, y equals to cotangent x, y equals to secant x, and y equals to cosecant x. In some countries, people cover only 4 basic functions instead of 6. In majority of countries, they cover all 6 basic functions. But for example, in France, in all countries in which they used French mathematical programs and curriculums, they are using 4 functions like sine x, cosine x, tangent x, and cotangent only. They do not use secant and cosecant. But in our country, as in many other European countries, Asian countries, Australia, and all other countries, people use 6. But if we talk about these functions, I'm talking about basic functions so far. 4 functions are 2 pi periodic, and these functions are sine x, cosine x, secant x, and cosecant x. And 2 functions are pi periodic. These functions are tangent x and cotangent x. So this is the definition of periodic functions. I just mentioned definition and gave you easy examples. We will be working with periods many times, each time talking about properties and graphs of all trigonometric functions, and definitely we are going to cover not only basic functions, but we will be dealing with modified versions of equations for all these 6 families. But because again, we talked about right now periods, and again, I need to mention modified version of the functions. And again, I am doing this quite briefly again, because I'm not pretending that you never had trigonometry. Definitely, I will be giving a little bit more details as well. But it is your responsibility to have your old notes from trigonometry class and start seriously reviewing this material. So, again, I talked about 4 families, functions, 4 functions basic, having 2 pi as a period, where I excluded tangent and cotangent, and 2 families pi periodic, which are tangent and cotangent. Right now, I am going to write a modified formula, and you will see what I'm talking about. So first I wrote down y equal to sine x. Now I have A sine omega is outside, x plus phi, just 1 second, please. You probably can be a little bit even scared seeing that modified formula which I wrote. This is a modified formula. This is a function which also from the family of sines, but there is a big difference between y equal to sine x and this formula. You now can see parameters. First parameter is A. Next you see omega. Next it is phi and plus k at the end. So you have here 2 letters from Latin alphabet, A and K. And you have here 2 letters from Greek's alphabet, omega, which reminds us W, but it is not W, it is omega, and phi inside of parentheses. And each of these parameters plays its own important role. Let's talk about the role played by each of these parameters, and I will definitely talk about period having one of parameters in this formula. Okay, let's start again with sine in this formula. And don't forget, this is the member of the sine family. So let's start with coefficient A. This is the coefficient in front of the symbol of the sine. What is the role played by this A?
Let's say vertical stretch.
What more precisely is the role?
Amplitude?
Starts the answer also as a word, it starts with A.
Amplitude?
Absolutely, yes. It is related to the amplitude. A itself is not an amplitude. We have, if we list all families of functions, 2 families of functions have amplitudes. Family of sine and family of cosine only. 4 other families don't have amplitudes, even though they all can have that coefficient A. Do you understand that? So this A, capital A, does not stand for amplitude itself. But what is that? It is equal to the absolute value of A. But this is only, and if I were you, I would immediately write that we can talk about amplitudes for only 2 families, for families of sine and cosine. All 4 other families do not have amplitudes. Now, what about the amplitude and why, let's say, only 2 families have amplitudes? The explanation is quite easy. Because only 2 families have graphs which have vertical limitations. All graphs for functions from 2 families, sine family and cosine family, will be having the highest level and the lowest level. It's vertically limited. It is between 2 restricted lines. And amplitude actually is a half of the height of entire graph. So basically you need to measure the distance between the highest point, the lowest point, it is the height of the graph, and divide by 2 and it will be your amplitude. But that coefficient in front of sine or in front of cosine will be telling you about half of the height. This why amplitude equals to the absolute value, because we never measure height or half of height in negative units. Your A parameter can be positive number, can be negative number. This is why we have that amplitude. Do you have more questions about A? So again, A is related to the amplitude for members of sine family and cosine only. For other families also easily will be having different A's, but there is no amplitude for 4 other families. Now let's move to omega. What kind of role is played by this omega, which, and I purposely wrote it in front of parentheses, because if it is inside parentheses, your first step, you are obligated to factor it out. So I am addressing this question to, excuse me, I cannot understand Chinese, unfortunately. Can you please use English and tell me about the role for omega? I really apologize. No way. And I am not planning to talk to anyone right now on telephone. Okay, so what about omega? Can you guess at least? Do you need my help?
Does it affect the period?
Absolutely, yes. It indicates what the period is. And again, for different families, we have different formulas. For all members from 4 families, for again, all members from 4 families, which are sine family, cosine family, secant family, and cosecant family. Again, sine, cosine, secant, and cosecant. Period. By the way, in many textbooks around the planet, very often for period, they use capital T. The formula for these families is, again, for 4 families, period is equal to 2 pi over omega. This y, when you look at y equal to sine x, look what we have for y equal to sine x. A is equal to 1 and omega is equal to 1. This y, 2 pi over 1, is 2 pi. And this y, we came to that conclusion that y equal to sine x has period equal to 2 pi. But the same formula will be working and for family of cosine and secants and cosecants. For tangent and cotangent, I will provide formula right now also, period equals for y, for families, you can write now for tangent and cotangent families, formula is, and I wrote it right there, pi over omega. Similar, but slightly different. Now it is pi over omega, but it is only for 2 families, for families of tangent and cotangent. Can I move now to parameter phi?
Yeah.
Yes.
Can you see it is inside of parentheses in the same company with x?
Yes.
Yes.
X plus phi. And my question is to everyone, what about the role played by this phi? What does it do?
Horizontal shift.
Absolutely correct. We can call it horizontal shift, we can call it phase shift. They are synonyms. You can use or. It's the same thing. Yeah, it is an important information about phase shift. So, and as any other phase shift, it is all the time will be moving into direction opposite to the sign which you have inside. I wrote this in general form, x plus phi, but phi can be 0. There will be, in this case, no phase shift. It can be positive number. It can be a negative number. If you have x, let's say minus 2, so shift will be 2 units to the right side, into right direction. If you have here in parentheses x minus 2, it will be moving horizontally 2 units to the left. But can you please write down that phi is responsible for the phase shift? There is no formula. We need to have particular equation to precisely talk about phase shift or horizontal shift and direction of that shift. Can I move to K?
Yes.
Yes.
And K is right there at the end of that equation. What about the role played by this K?
Midline.
No. More guess?
Vertical
What?
shift.
Excuse me?
Vertical shift.
Yes. This is the parameter responsible for vertical shift. But as it is all the time working with vertical shifts, here, if it is K with plus as a number, positive number, it will be lifting that graph so many units up into absolutely same direction as this sign is let's say indicating in our equation. If you at the end have, let's say, plus 10, it will be 10 units up. If you have at the end minus, let's say, 5 for K as a value, it will move entire graph 5 units down. Can you please write down that K here indicates if it is not 0, definitely if it is 0, there is no vertical shift. The K not equal to 0 indicates that this graph has a vertical shift, but in the same direction as we see in our equation of the sign in front of that K, positive or negative. So this about, again, short information about the period and amplitudes, the 4 different formulas for periods for certain families, and roles played by C parameter and K parameter. But I have right now more actually questions. We already talked about these functions, but what is the nature of all trigonometric functions? Can you, in general, describe the nature of that function, thinking about possible definitions of that function? What do we use to define that all functions? Did you understand my question? I can be more specific. Should I give you more details?
Oh, a little.
Again, when we talk about functions, and so far we talked only about functions of one variable, because in calculus 2 you will start another material, functions of multi-variables, when you will have not only one independent variable. But so far we have one independent variable and we have one function, which is a function which can be translated like a dependent variable, because if we translate word function from Latin in English pronunciation, it is a function from Latin into English, translation is dependent variable, which looks natural. If we have an independent variable, we need to have a dependent variable. So what do we use in these trigonometric functions? What do we consider as values for x? Do we use angles?
Yes.
Oh yeah.
Yeah, and these angles can be measured actually in degrees as a measure and in radians. Radians are more commonly used because radians basically are regular real numbers, and we can choose any positive or negative, and definitely we can deal with negative angles in degrees as well, but in our course we will be more often actually using radians. Excellent. So which means x is an angle represented by its measure. Excellent. What about y? Is it an angle as well?
I don't think so.
But I don't think so. Okay, easy question. I will try to recall some information which you actively used in trigonometry course. Let's say your angle is 30 degrees. What is the value of sine of 30 degrees? Easy question for people who cover trigonometry. Guys, long time ago I told you, start reviewing trigonometry, start reviewing trigonometry. Again, do you need my help? Again, this is that question which I'm asking. Sine of 30 degrees equal to what number?
Pi over 6.
No, pi over 6 is equivalent in radians for 30 degrees. Yes, 30 degrees is equivalent to pi over 6. You can write sine of 30 degrees, you can write sine of pi over 6, but if they have same value because it's the same thing written in different ways. Okay, do you understand that you need to do a lots of work reviewing trigonometry? Because again, I'm not going to do that with you. You need to know all this material. This is your obligation. I cannot erase trigonometry covered for you before and pretend that I need to teach that course again. Ladies and gentlemen, sine of 30 degrees equal to 1/2. And you can see it is not with degrees or it is not in the radians. So it is equal to that number. Now, okay, I do not want right now to waste more your time, but all trigonometric functions are ratios. And in these ratios, we are using coordinates of the endpoint of each of these angles on the trigonometric circle. So I already know what I have to do. Probably I need to at least remind you definitions of all these trigonometric functions the next time when we meet. But again, the situation can be very dramatic, and I am not kidding, and I am not planning to scare anyone. But please seriously listen to what I say. Guys, you are missing entire trigonometry right now. Even though you covered this just as a level below, you need to restore it. Or you will have horrible situation with trigonometry. So again, I already started chapter number 7. I mean, in your homework also you can see that. And please, again, be prepared for tomorrow's test, and we will be very briefly but quite seriously covering trigonometry. So I need to end right now our meeting unless you have some questions which you like to address to me. Do you have any question in your mind right now which you like to ask me about?
No, not at the moment.
No? Okay, is it okay if we end today's meeting right now?
Yes.
Yeah.
Okay. 1 second, please. Are you interested in getting today's discussion, I mean, a link to that?
Yes.
Okay.
Yes.
Okay, okay, guys, I understand. So everyone, goodbye, and please review material for this test So I hope everyone can get really good looking grade. Have a nice, beautiful day.
You too, Professor.
Bye-bye.
Thank you. Bye.